Right. Today we are going to start a new lesson. Um, the name of the lesson is Unit 4.4. We are going to discuss fundamentals, building blocks of a CPU. And we have another topic called storing bits in digital circuits. There are two separate topics here. Today I am going to discuss the first topic, building blocks of CPU. As you know, the central processing unit is a very complex circuit. So when scientists design the central processing unit, they have used combinational circuits and they integrate them together in order to develop such a complex circuit. So under this topic, you have to discuss two main areas called half adder and a full adder. They are actually circuits. They are used for doing simple additions. So this is a selected part from the complex circuitry for our A-level syllabus. Right. Let's see from here. I would like to remind you basic addition in decimal number system. Now everybody knows it, but it is useful for our topic. Now for example, if we want to add these numbers, we have 25 and 31. We are going to add these numbers together. So what we do, we have 5 plus 1, it is 6, and 2 plus 3, it is 5. So we know the sum is 56. The total is 56. Now everybody knows how to do the simple addition here. Now when we think another value, we take another example here. In this particular example, I have 39 here and 16 here. I'm going to add these two. Now what is happened here? We always add 9 plus 6. It is 15. It is 15, but we do not put 15 here. Instead, what we do, we put 5. And we have tens. We have 10 here. That is the value taken out from the answer here. It is called carry out. This is carry out. So what we do, we are going to get this number 10 and add here. That is called as, this is carry out, it is carry in. It is carry in because there is a value to move from here. The answer is 15, but 10 is moving from here as carry out, and it will be added to this place as a 1. But we know actually we have 10. The real value is 10, but we take it as a 1, that is carry in. So we say 1 plus 3, 4, and plus 1, 5. So we complete the calculation like this: 39, then 39, 49, and 55. How it has happened? So there is a way of getting a carry out from the sum of two numbers and edit it into the next. We are moving it forward here, that is called carry in. That is the way of doing the calculation. I think all of you know this type of calculations are done in very small classes such as grade 3, 4, 5. But you should remember these two: carry out and here the carry in. Now what we are going to do, I would like to go for binary mathematics. So just remind you that is binary addition. Binary addition. Why? Binary addition is the method used in computers to do calculations. We are going to see such circuits. So before this, you should get an idea about binary addition also. If you take two numbers, for example, I take 5 here, and I want to add with see. No, should be like this. Now I have two binary numbers. What is this? This is 5. We have 1, we don't have 2, and then 4. 4 plus 1, it is 5. Here we don't have 1, only 2. This is 2. So the answer should be 7 after adding these two. Now what do you think about 1 plus 0 is 1. 0 plus 1 is always 1. 1 plus 0 is 1. We take the answer. We have 1, 2, and 4. So it is 7. So this is the way of doing a binary calculation or binary addition. I just remember you. I take another example of binary addition here. We have a value like this. I have 1, 1, 1 here. 1, 0, 1, 1 in this place. Now we have to think. 1 plus 1. 1 plus 1 is 2. 1 plus 1 means 2 in binary or in any number system. 2 in the sense 1, 0. So what we do, we put 0 here, and we have a value called 2. We take it as the carry out. Now it is moving forward here as carry in as 1. We have carry in. Then what may happen? We have 1 plus 1 plus 1. That is 3. 3 in the sense 1, 1. 3 in the sense 1, 1. So we have 3 here. As carry out for the second time, we have 3. It is 1, 1. We put 1 here and take the 1 forward. So then we can add 1 plus 1. It would be 1, 0. So we put 1, we put 0 here, and 1 comes to here. Actually, what is this value? This is 7 in decimal. What about this 1 and 2? It is 3. how do you understand the total? 0, we have 2, we don't have 4, we have 8. 8 plus 2, it is 10. So 7 plus 3 is 10. This is the way of adding numbers. Right. I think you may have taken idea about binary addition also. We have discussed binary additions in previous classes, so just take this idea, and we are moving to the topic called half adder. Right. Now, what is a half adder? Topic is half adder. Half adder means a circuit. It has designed by using the circuits we have discussed in previous classes. But what is the purpose of half adder? Half adder is a building block in a central processing unit. What it can do? It can add 2 bits together. It can add 2 bits together. So if you take a truth table, for example, you have suppose A and B, you have A and B. Half adder is used to add 2 digits only. Remember, the half adder cannot add more digits, only 2. This is the simple calculations computer has ever done. So these 2 bits can be in this status. It can be, the both values can be 0, or A is 0 and B is 1, A is 1 and B is 0. Both values can be 1. These are the possibilities of 2 digits, as we have 2 digits. Now we are going to think about 2 outputs. After entering these numbers, we always think about carry and sum. This is important. Why? This time we are going to discuss 2 outputs with 2 inputs. We have 2 outputs. How we get these 2? We add 0 plus 0. What's the total? 0. So sum is 0 here. 0 plus 1, it is 1. 1 plus 0, it is 1. This is actually binary addition, not the Boolean algebra. Remember, you have to remember it. Binary addition. Then 1 plus 1. 1 plus 1 means 2. 1 plus 1, it is 2. 2 means 1, 0. 1, 0. So sum is 0. 1 is moving as carry out here and come to this place. So 1 here. Now try to get the idea. After adding 2 digits, we get the sum like this. But when we come to 1 plus 1, that is 2. So sum is 0, carry is 1. So there is a carry bit now. it has moved forward. So for the other uh, combinations, we don't have a carry. It means 0. Carry is 0. So we fill the truth table here. This is the if you think about getting the total 1 plus 1, it means 1 0. In order to get 1 0, you have to prepare a structure like this. There are two columns in the structure, sum and the carry. So in previous cases, the carry is 0. Sum has got different values, but here the carry is 1, sum is 0. Now we think about developing a circuit in order to get the output. And this is the logical design, but we want to convert it into a physical structure. Now we are going to see how the sum has come. Sum has come according to the exclusive OR gate. See, if both bits are equal, the output is 0. If both bits are different, both inputs are different, output is 1. Here we have different inputs, so output is 1. We have equal input, output is 0. So XOR is used here in order to get the sum. What do you think about the carry? We have two values. All these situations we have taken 0. So it means if both values are true, 1 into 1, we have taken 1. In other cases, we have taken 0. What is the basic gate here? It is AND gate. Now, in order to add 2 bits, we need such a structure. We see AND gate and the XOR gate are used in order to get the sum and the carry. As there are 2 outputs, we see there are two different lines here. So what we are going to do, we are going to think of drawing the output. Just take example. If I have 2 variables as A and B, I input these 2 values, these 2 binary values into a structure. This is not a gate, this is the idea only. We use the half adder. We use half adder. So half adder provides carry. It has got carry and sum. Okay, right. Now see, in order to get an idea, you have to see the idea. We have 2 input. We pass that into a half adder, so then we get the carry and the sum. Okay. Right. So now we have taken an idea. What we can do now, we can draw a circuit. here sum is coming from XOR gate. So we just draw, we have A and B as input. We draw XOR gate here. A and B, they are the input. So XOR provides sum, and we need AND gate also. This is the AND gate. We have A and B. They provide carry. By using A and B variables, we can get both into two gates. Now sum is taken from XOR A XOR B, A XOR B, that is sum. So we see that A XOR B. What about carry? That is A and B. A and B provides AND. So half adder is a circuit. It provides these two. Then computer can display. Computer can add these two numbers by using these two combination of logic gates. That's the idea. So you should be able to draw the table and draw the circuit also. But what is important here, you know, there are different ways of drawing or getting XOR, representing values with XOR. So this diagram can be varied in different occasions. What we have drawn here, according to the syllabus, we have taken the most simple diagram for getting half adder. It can be varied, but this is a simple diagram. So we have to think about the same structure with different circuit designs also. Right. Then I'm going to discuss full adder, the second technique. What do you think about full adder? Right. Now in binary additions, if you have 3 bits to add together, earlier half adders can add actually 2 bits, but this time we have 3 bits. If we have 3 bits, there is a structure called full adder. Full adder. A quite complex truth table is required in order to show you how 3 bits can be added together. We are going to show it. Okay. So I'm going to use the entire boards for drawing that circuit this time. The truth table here, not the circuit. So I take as there are 3 bits. There are 8 possibilities. So I take A here, and then B, and C. We have basic values. A can be 0, 0, 0, 0, 1, 1, 1, 1. B can be 0, 0, 1, 1, 0, 0, 1, 1. What about C? C can be 0, 1, 0, 1, 0, 1, 0, 1. The method is we are going to find the carry and the sum. Carry and the sum. I think we need more space here, so I will just the truth table is so large, that's why I need say carry and sum. If you get 3 bits, now we have 3 bits here, so we are going to add. You know how to add it. 0 plus 0 plus 0, sum is 0. 0 plus 0 plus 1, sum is 1. 0 plus 1 plus 0, sum is 1. 0 plus 1 plus 1, sum is 2 this time. Sum is 2. If it is 2, we put 0 here. We have a carry bit here. This is 2. This is 2. Then 1 plus 0 plus 0, it is 1. 1 plus 0 plus 1, it is 2 again. 2. So we put here and 2 comes as the carry bit. 1 plus 1 is 2. So we put 0 here. 1 comes here. And 1 plus 1 plus 1, it is 3. 1 plus 1 plus 1, it is 3. So we put 3 here, 1 comes here and another one here. 1 plus 2, it is 3. This is the way of taking, sum and carry. Now, you may have remembered what we did in the half adder technique. We use exclusive OR gate in order to get the sum, and we use AND gate in order to get the carry with 2 bits. Now we are going to apply the same technique here, XOR gate here and AND gate here in order to get the sum and carry. This time, in order to get sum, we need to use the XOR gate, but we have three variables. If you have got 2 variables, we know A XOR B. But here what may happen, A XOR B XOR C. It should be like this. A XOR B XOR C. So with this technique, what I'm going to do, I'm going to just a moment,